The X-44 Manta might sound like the name of an exoplanet, but in fact, it is an aircraft designed to perfection inspired from the F-22. Even though it was cutting edge at the time, it never made it to the skies. It was deemed the most terrifying aircraft ever built, yet it remained hidden. But it was recently announced that the X-44 Manta will officially replace the F-22 Raptor. What changed? What happened? Watch this video to find out. Back in 1999, Lockheed Martin proposed the development of this delta-shaped stealth fighter, which aimed to remove the need for a conventional tail section found in the F-22. Instead of relying on a combination of vertical and horizontal control surfaces, the Manta sought to use the thrust vector control. This system involved directing the engine's thrust to provide the aircraft with exceptional maneuverability and acrobatic capabilities. However, despite its innovative design, the X-44 Manta project ultimately did not come to fruition. About 20 years later, the concept of the X-44 Manta seems to have resurfaced in the official renderings of the U.S. Air Force's aim for air superiority fighter jets. This fighter is currently being developed under the Next Generation Air Dominance program, leading to speculation about the potential incorporation of elements for the X-44 Manta into America's next top-of-the-line fighter. In an announcement last year, the U.S. Air Force surprised the world by revealing that they had already designed, built, and tested a prototype aircraft as part of the NGAD program. This new jet is expected to surpass any previous fighter in terms of advancements, with the aim of not only engaging in combat with advanced fifth-generation fighters produced by adversaries like Russia and China, but also establishing dominance over them for decades to come. Interestingly, around the same time, the Air Force unveiled an image celebrating its anniversary. This image showcased a wedge-shaped aircraft without a conventional tail section, sparking speculation about the potential connection between the artist's depiction and the NGAD program announcement. It led some to wonder if elements of the X-44 Manta design had influenced the ongoing development of America's next-generation fighter. Since then, official images released by the Air Force, as well as renderings from renowned aviation companies like Lockheed Martin, have frequently depicted aircraft with similar wedge-shaped designs. Many, including myself, have drawn comparisons to Northrop's advanced but ultimately overlooked XB-35 Black Widow, which serve as a stealthy precursor to this tailless configuration. However, Northrop is not the only player in the field when it comes to constructing stealth fighters without conventional tail sections. In fact, based on various artist renderings and the practical constraints associated with developing a new fighter within a limited timeframe, the X-44 Manta could be seen as an early iteration or a precursor to what has already emerged or will potentially form part of America's next cutting-edge fighter in the skies. The name X-44 Manta, or multi-axis no-tail aircraft, directly conveys the concept's purpose. After decades of rapid fighter development, certain features have become standardized expectations for a capable tactical aircraft. Traditionally, fighter aircraft have employed a conventional tail section comprising vertical and horizontal control surfaces, while the F-22 and later the F-35 incorporated slightly different tail designs compared to non-stealth fourth-generation fighters like the F-16. The X-44 Manta pursued a similar objective of achieving exceptional maneuverability without relying on multiple tail surfaces. By eliminating the conventional tail section, the X-44 Manta aimed to significantly reduce its radar signature, resulting in a stealthier fighter than even the highly capable F-22. To bring this concept to fruition, Lockheed Martin joined forces with NASA to explore the feasibility of creating an agile fighter that could operate without relying heavily on a traditional tail for maneuvering. Such an aircraft would heavily rely on thrust vector controls to alter the fighter's flight path, thus necessitating a close collaboration between the two organizations. By successfully developing an acrobatic fighter capable of maneuvering without a conventional tail, the X-44 Manta aimed to push the boundaries of aircraft design and exploit the potential of thrust vectoring technology. This approach not only promised enhanced stealth characteristics, but also sought to optimize the fighter's maneuvering capabilities. NASA had achieved notable success in utilizing thrust vector controls on a high-performance fighter known as the F-15 Active. The result was a fighter that surpassed the capabilities of the legendary F-15 Eagle in almost every aspect. In simple terms, thrust vector control allows the adjustment or redirection of the jet engine's nozzle. In some aircraft, like the F-22 Raptor, the nozzle can be aimed in a single plane, either upward or downward. However, in other jets like Russia's fourth-generation Su-35, the nozzle can move in 360 degrees, offering even more extensive maneuvering options for rapidly changing directions during head-on engagements. This capability provides fighters with enhanced agility and maneuverability, enabling them to outperform adversaries in combat scenarios. The F-22 Raptor's thrust vectoring capability allows the pilot to direct the aircraft's nose and weapons downward at an enemy jet during a close-range encounter while still maintaining its original direction of flight. In a dogfight scenario where two fighters are vying to outmaneuver each other and achieve a weapons lock, this ability provides a significant advantage. Jets like the F-22 and Su-35, equipped with thrust vector controls, can change directions with far greater agility than advanced jets lacking this capability. Taking inspiration from the F-22 design, Lockheed Martin proposed using it as a starting point for a technology demonstrator. The aim was to showcase the capabilities of a fighter design that deviated from conventional norms. Rather than embarking on an entirely new clean-sheet fighter development program, the focus was on creating an aircraft without a conventional tail section. This approach allowed Lockheed Martin to leverage the proven capabilities of the F-22 Raptor, which, although not the most recent stealth fighter from the company's Skunk Works, serve as a suitable platform for demonstrating the potential of this innovative technology. The F-35 Joint Strike Fighter had already begun test flights 3 years before the F-22, and it is currently considered America's top fighter in terms of engaging enemy jets. The F-35 already incorporates thrust vector control, making it a logical choice for an experiment focused on that specific capability. However, the X-44 Manta was not the only F-22-based concept being considered at the Pentagon during that time. As the world's first operational stealth fighter and the inaugural aircraft of the 5th generation of jets, the F-22 Raptor is arguably the most formidable air superiority aircraft ever flown by a nation. Given its groundbreaking design and capabilities, it makes sense that the United States would explore additional roles for the F-22 program beyond its primary air superiority mission. While the X-44 concept aimed to remove the F-22's tail to enhance stealth, another effort known as the Sea Raptor envisioned deploying F-22s on America's supercarriers. This would provide a jet capable of flying faster, covering greater distances, and carrying more ordnance than the F-35C as destined for deployment on naval carriers. The F-22 Raptor had already set itself apart from other fighter aircraft by incorporating stealth as a core element of its design philosophy. In contrast, previous highly capable air superiority fighters like the F-15 relied on superior performance alone, only incorporating radar-absorbent coating, later to reduce detection. The F-22 Raptor's design was specifically aimed at minimizing or evading detection. Its powerful Pratt & Whitney F-119 engines allowed the stealthy fighter to reach speeds of up to Mach 2.25, while thrust vector controls enabled it to maneuver swiftly and evade incoming missiles. Today, the F-22 remains the most highly capable air superiority fighter globally, and its superiority was even more pronounced in 1999. However, even the remarkable F-22 could have benefited from increased stealth capabilities, which is where the concept of a tailless delta design like the X-44 Manta comes into play. The DNA of the X-44 could potentially find its way into the future design and capabilities of the Air Force's upcoming top-tier fighter.